What do you think about when you hear about a time machine? Some may want to look into the past to see distant relatives, while some, on the contrary, want to travel to the future in order to look at humanity from the side in a couple of decades. In any case, it sounds like something fantastic, or maybe not. It's hard to believe, but today there are actually ways to travel in time. I tried to figure out exactly how this can be done, and right now I'm ready to share the results. There are currently no existing time machines. No matter how hard scientists try to get close to creating one, they lack the knowledge, materials, and people needed to succeed. But who knows, perhaps right now among you is a great physicist and at the same time an engineer. My task is to introduce you to a theory. Your job is to hear it. Possibly, with time, you can give the world something very incredible. What films are made about, what many dream of, something that no one has ever seen. There are three main hypotheses for time travel. The first follows from the theory of relativity of Albert Einstein. According to his theory, a leap into the future can be made by moving at the speed of light. This will be possible because time for an accelerated person slows down compared to when standing still. Simply put, traveling at the speed of light, you can circle the Earth 10 times around the equator in about 1 second. But for me, sitting still and creating a video, about 3 seconds will pass. If we consider this on a more serious scale, imagine space travel. Suppose you were to travel at the speed of light to the star system Alpha Centauri. Meanwhile, I would remain on Earth to wait for your return. As you explore the vastness of the universe, I would continue getting older. For you, 6 years would pass. For me, it would be 10. After returning to Earth, you would see how everything around has changed. Your children would grow up. The house would be completed. The technologies you knew would become obsolete. However, you'll still be young and take a huge step into the future. The second hypothesis is long-term freezing. According to this principle, a living organism is frozen for a certain time, after which it's restored and continues to live an ordinary life. But there's a small problem. The human body doesn't work like the body of a cold-blooded frog, and scientists can't do anything about this yet. Therefore, we'll have to hold off on freezing ourselves for now. The third hypothesis is about improving our knowledge in the field of quantum physics. If we can learn all the subtleties of this science, we'll learn how to teleport information and physical objects. It'd be great, but this is an incredibly difficult task for modern science. So let's leave this hypothesis for future generations. Of all that I've listed above, the very first hypothesis, the speed of light, appears to be the most realistic. Famous physicist Stephen Hawking long thought about its connection with time displacements. He made several attempts to prove that this is possible, even in theory. In his latest book, published in 2018, the scientist made his final assumption. I'll rely on him as we move forward. So, how fast is the speed of light? It's believed that in a vacuum, it's 299,792,458 meters per second. That's 983,571,056 feet per second, or 299,800 kilometers, or 186,287 miles per second. In the presence of air, the speed will be less, but not by much. It's unlikely that we will be able to complete a temporary leap in airspace, so we won't dwell on minor differences. Now that we've figured out the speed of light and the travel environment, what remains is to learn exactly what kind of device can help us to accomplish this. The fastest man-made space object in history is the Parker Solar Probe. Its current speed record is approximately 393,000 kilometers an hour, or 244,225 miles an hour. but it's assumed that by 2025, it'll be able to attain a maximum speed of 692,000 kilometers or 430,000 miles an hour. Very good for a space probe, but still not enough for time travel. The speed that it will develop will be approximately 0.064% of the speed of light. Do you see how little this is? But let's put aside engineering formalities, features of the human body, and some laws of physics, and just try to get closer to the dream. To achieve at least 1% of the speed of light, you'd need to combine the capabilities of 16 such devices that work simultaneously at full power. To achieve 100%, we need 1,600 units. One would think that this is the time machine we're looking for, but if everything were to be so simple, scientists would already have long ago begun to act. Firstly, the cost of one such project amounted to about $1.5 billion. After making simple calculations, I found out that at least $2.4 trillion would be required to create 1,600 such Parker solar probes. That's a pretty large sum for a dubious machine. Secondly, no one knows how such a device would behave. It may not show any results. An accident could happen. Anyway, nothing like this has ever been built. In addition, to accelerate to the speed of light, you'll need a huge amount of fuel. To maintain this speed would require an infinite supply. There are no gas stations in space yet, so that's not what we need. Let's go to Plan B. According to Hawking, one can also travel in time with the deformation of space-time. If this occurs, a so-called wormhole is formed, the original space tunnel. Moreover, you can move both toward the past and the future. It all depends on the type of wormhole itself. To visualize how it works, draw two dots on a piece of paper. There will be some distance between them, which will take time to cover. But we want to deceive time, so let's play a little trick. Folding the sheet in half, you'll see how the 2 points of space connect. The distance between them will be unnoticeable and can be covered in a split second. This is how wormholes work according to the theory of relativity. It would seem that everything is quite simple, but it lacks one important detail: exotic matter. Before a wormhole can be used, it has to be filled with this substance so you can enter from one end and exit from the other. In the absence of such matter, the portal through space and time will slam shut even before you have time to move from one end to the other. This type of matter is still unknown to modern scientists. But we can roughly assume how a time machine based on a wormhole would work. For a successful journey, one end of the wormhole must be accelerated to near light speed and then returned to its original state. Sounds pretty complicated. That is why even the great minds of modern science can't create anything like this. But maybe there's a chance to find something similar in space. Yes, there is, and this chance is much greater than you might expect. It's believed that a wormhole is a combination of black and white holes. All these objects have a strong curvature of space. However, the wormhole has no event horizon like a black hole, a trap from which we can't return. Surprisingly, such temporary tunnels don't contradict the laws of physics. But for now, in space, there isn't a single confirmed candidate for this role. All the hypotheses and theories previously described speak mainly about traveling into the future. Yes, that's right. I said that a wormhole can be used to travel into the past. But there's still a lot of work to be done and also many years of waiting. What do we have for now? In a sense, you can leap into the past without leaving your home. It's enough just to look out the window at the sky. You'll see the light reaching us from planets and distant stars. To overcome the distance to the Earth, it took hundreds, thousands, and even millions of years. Simply put, now you see what happened incredibly long ago. In the meantime, scientists are trying to solve all the secrets of space and time. Be sure to like this video and don't forget to subscribe to the channel. Also, click on the bell quickly to make sure you don't miss out on new and important future releases.